Hi, good evening. I'm Deepa, and welcome to day two of QuaNTA NXT, Globant's premier quality engineering and automation web conference. I'm sure you had some great takeaways from yesterday, and today too we have some amazing speakers lined up. Without taking a lot of time, I present to you our first speaker, Vanya Seth. Vanya is the head of technology at ThoughtWorks and is a renowned speaker covering varied topics including cloud architecture, distributed systems, event driven architecture, and digital business transformation. Over to you, Vanya.
Hello, everyone. Good evening, and thank you so much for joining us today, sparing your time in the evening after work. So, I'm sure there is something that's valuable that's coming your way. And by the way, I'm Manya. I'm the head of tech for ThoughtWorks India, and I'm here to talk about some of the key trends in generative AI that every quality analyst must know. And without any further ado, let's get started. So this is how the agenda for the next 35 minutes is going to look like. I'm going to cover this talk in four sections. The first one is about generative AI is omnipresent, it's everywhere, and why it can't be ignored. We'll touch base on the generative AI fundamentals because I'm assuming it's possible that a lot of you might not be completely aware of the fundamentals. So we'll take a look at that. And then there are two main, perspectives from which I'm covering the trends. One is AI in testing. That means how do you leverage AI tools for your testing? And the second aspect is testing the AI itself, right? As as generative AI becomes a lot more omnipresent and there is AI embedded in every software system that we build, it's very important that as a quality analyst, I understand what is the mechanics or what are the thought processes that I need to have for testing the AI system itself, right? As I said, generative AI is everywhere, right? Right from multitude of startups that have come up in that space, right from the lot of focus on tools, open source or organizations who are putting in a lot of money to churn out large language models or any other type of generative models in that space. I think open source is also quite really active. I think of this like the JavaScript moment, right? Like when there was a new JavaScript library every day. I think in generative AI as well, it's pretty much the same, that there is a new uh, LLM open source version, or there is a new tool, AI tool in the space that keeps coming published, or that keeps popping out every brand new day, right? So it's fair to say that generative AI is everywhere, right? And it would be an understatement of the year that the interest in generative AI has grown exponentially. Right now, you can see some of these stats on the right hand side from Statista, which talks about that ChatGPT hit 1 million users in just about 5 days. Right, I'm sure all of you are aware of all the other uh, popular software systems that you see on the left hand side, like Netflix, Airbnb, Spotify, Instagram. You can see the number of days it actually took them to get to 1 million users, and how exponentially ChatGPT has sort of grown, to a million users, and now it's hitting 100 million users, right? So I think you can see that there has been exponential growth since the time that it came out in the Q4 of 2022, right? And that's where it's fair to say that it's time to act now, right? The reason it can't be ignored is because it's getting that sort of traction from the industry. There are huge investments that large corporations and countries, for that matter, are making in generative AI space, right? Right from enterprises to scale ups to startups, and everybody needs to act now, right? I know there are a lot of risks yet. There are a lot of confusions and clarifications that are required from a regulatory and compliance aspect, but a greater risk is to not act at all, right? So if you're not acting and taking stock check of what and where you are in your AI journey to adopt and embrace generative AI, it might be too late, right? So the message here is, uh, this is a technology that has gotten the interest of not just technologists but the common people as well, right? Think of this like AI has been commoditized. Right now everybody, whether they are in technology or not, knows how to think about using chat gpt, right? So from the background, AI has come into the foreground. Right now everybody knows about it. So it's very very easy to say that the time to act on thinking about generative AI in your ecosystem is now. And this is just for fun. As I was saying, there are many, many startups that have come up in this ecosystem. And if you just, remove that hood, you'll see that probably that startup is doing nothing but an API call to GPT-3. So this is, anyways, just for fun, but just to give you a magnitude that, there is so much innovation that's happening on top of what OpenAI and a lot of other large organizations have provided as a service. And on a much more serious note, I would say that AI bears, in comparison to other revolutionary general purpose technologies that have actually transformed the business, right? If you start from the year 1450 when the printing press came in, right, to electricity, to the assembly line, to how mobile internet sort of revolutionized and brought computing power into the hands of the customers in a handheld device, right? All of these were inflection points for in some way or the other for businesses, for enterprises, for consumers, for that matter, right? They changed our lives, right? There has been no looking back. And I can very confidently say that probably in this decade, AI and ML is at the same juncture where all of these were when they kickstarted, right? So we are definitely ushering into the era where we are going to see an AI revolution, where we are going to see groundbreaking innovation on top of AI. And because the rate of diffusion, as I was mentioning earlier, is extremely high, right? And the question is, are you ready about understanding this, embracing this, and seeing how can you evolve with this technology? And with that, let's come to the generative AI fundamentals. Just to give a very simple view, right? What is the difference between traditional AI and generative AI, right? On the left hand side, you see traditional AI, right? Where I'm talking about a simple classification model which can tell me whether it's a cat or a dog, right? So, given a picture, which is this a cat or a dog? This model is telling me, yes, it's a dog, right? Now, the generative AI, on the other hand, is imagination, right? It's telling me, imagine a dog with a cat, and it's going to give me this picture, right? So, this is the fundamental difference between the traditional AI and generative AI, right? Here we are talking about simplistic models which are doing one thing good at a time, right? They leverage the labeled data that they are leveraging to make this decision whether this picture belongs to a dog or a cat. And when it comes to generative AI, right, it's about creating something new, something that has not existed before, just by the units or the values that you have seen before, right? So it's creating something new, it's imagining something new. And that's the fundamental shift from traditional AI, because traditional AI is not generating or creating something brand new, but generative AI, on the other hand, has that capability to create a new image, a new video, a new text, a new code that it might not have seen before, right? As I said, what is generative AI? I think that's a question. It's a large language model, it's artificial intelligence, it's a neural network. I think the answer lies here that generative AI refers to type of artificial intelligence that can create or generate new content, such as images, music, or text autonomously based on the patterns and examples that it has learned from, right? So if you think of an intelligent supercomputer which has a brain, this generative AI model is running or is part of that brain. And whatever you teach it, just like a human being who's super smart and intelligent, it learns from the patterns, it learns from the examples that it encounters, and then it has, in a very creative spirit, the ability to create or generate something absolutely new which it might not have seen before, right? So that's the idea of, in a very simple terms, of what is generative AI. Now, it's not just text, When it comes to generative AI, all of these are the various types of models that are available that are capable of generating text, images, audio, video, music, right? So these are the various popular models that are available out there in the wild, right? For images, for example, Stable Diffusion, or from Stability AI or Midjourney, these are the popular ones, or that matter, DALI, right? These are the multimodal models. They are capable of producing images as well as text. Then all of these, as you can already see on your screen, are some of the popular models that are capable of generating variety of forms of data, right? Not just text for that matter. And when it comes to generative AI, I think large language models is definitely one very strong uh, aspect of it. I'm not saying that generative AI is only about LLMs, but it's largely, that's the popular discourse because that's what has actually changed the way the industry is looking at it, right? It was the release of ChatGPT, which is a large language model, which actually brought around this fundamental paradigm shift, right? So just to introduce large language models, as you can see yourself, right? LLMs have this unique ability to generate high quality, coherent text that is often indistinguishable from that of a human being, right? And as you can see from this animation, which has been taken from a Google blog, that as the number of parameters in the model increases, its capability to do variety of tasks increases, right? It develops a linguistic understanding. It starts to understand language. It can do various tasks like translation, summarization, question answering, code completion, common sense reasoning, or pattern recognition for that matter, right? So you can see as the model becomes larger in terms of number of parameters, it becomes a lot more capable. As I was mentioning earlier, usually these large language models are trained on huge data sets, right? Typically greater than zero point 0.5 terabytes, because even the smallest of large language model that's out there is tuned or is sort of trained on huge amounts of data, right? And they have lots of parameters between say 1 billion to 540 billion, and depending upon the parameter size, their capabilities are going to change, right? They're usually based on the transformer architecture. If you have not heard of this term, I would request you to go back and read up more about this. They are based on self supervised training. And at the other end of the spectrum, when it comes to consumption, there is a new paradigm that's coming into place, which is called as prompting. Now, earlier, we used to interact with websites with clicks, with mouse, with clicking buttons, and it used to take us through workflows. Now, the new paradigm of interacting with these large language models is known as prompting, right? And with this prompting, it has sort of commoditized how I want to express my question or my task such that I can give that as an instruction to the large language model, right? And LLM, for that matter, has many diverse, powerful capabilities, which I was showing you in the previous slide as well. It can generate text, it can summarize text. So if you have a large article, you feed this to the large language model, and it can help you summarize with the key points and the key messages in that article, right? It can help you rewrite, right? To give it a rough sketch of ideas or notes, and it can create a nicely crafted, beautifully written document which can be used, right? It can do question and answering, right? I can engage with a large language model in a conversation where I give it a question, and based on its world knowledge, right, it answers that question. So for instance, it's not entirely known what OpenAI has trained their GPT-4 or GPT 3.5 on, but you can imagine that um, it is capable of doing question answering based on the world data that's available on internet, right? The publicly available data that's available on the internet, right? And of course, a lot of specific when it comes to code, or it comes to grammar, it comes to language history, and a lot of those semantics which ChatGPT has learned to be able to do a lot of question answering on top, right? So the but one thing to bear in mind is that a lot of these capabilities would depend on how have you trained your large language model, what is inside the brain of that large language model, right? If your large language model doesn't understand or doesn't have the linguistic capability, there will likely be hallucination, right? And therefore you see that chat gpt, which is powered say by gpt 3.5 or gpt 4, can really do well because it is trained on huge amount of internet scale data that the entire humanity has produced, say in the last 50 years or so, right? But coming back to the capabilities, the large language models can help you extract information from a large piece of text. Imagine going through large legal documents, and can I get that help from my large language model to extract some of the key paragraphs or some of the key messages pertaining to a specific topic that I'm looking at, right? I can search, I can do a similarity search, I can classify information, and I can then cluster also information, right? So these are some of the capabilities that are possible with a large language model. Now, another term that gets used often is foundational models. Now, what are foundational models? Foundational models, also known as the base models or the pre-trained models, are large-scale machine learning models that have been pre-trained on vast amounts of data, typically from diverse sources, right? So foundational models are these pre-trained models that exist in the market, right? So you can say that your GPT-4, your GPT 3.5, or your Llama, right? All of these are foundational pre-trained models that have been trained for years together, right, on extremely high compute intensive infrastructure, which is extremely expensive and extremely energy consuming to get to a state where you see them today, right? ChatGPT, as I was mentioning, is definitely an example of some of these foundational pre-trained models that exist out there. These are some of the other examples. There is Amazon Titan, BERT, DALI, Stable Diffusion, and and many, many more on this slide. Now, I think after covering the fundamentals of generative AI, let's take a deep dive into the first segment of AI in testing, right? How do you leverage AI, and specifically generative AI, in testing as a quality assurance engineer? Right. And before we do that, before we look at some of the trends, it's really important to look at what is the meaning of all of this AI emergence on the software development lifecycle, right? How does it impact the SDLC, right? And this is where I love to think of this human AI augmentation, right? The future knowledge worker is like this, right? That you're pairing with a machine, right? You're taking machine as a pair with you, and there are pretty much three aspects that you're looking at, right? You're learning with AI, right, where you are leveraging the capabilities or the specializations that that machine has and treating them as a subject matter expert to learn with it, right? So I'm sure you have seen a lot of prompts out there which says how to learn data science in 30 days with these prompts with your chat gpt, right? So you can definitely create a learning pathway for yourself, because that large language model, which is specifically chat gpt in this case, or maybe a bard in if you're using google, has learned all of that information, and now it can help you as an sme if you ask it the right questions to help your learning journey as well, right? The second thing that you can do with this human ai augmentation is plan with ai, right? Sort of how do you create or break down a complex problem statement into simpler tasks, and then you plan them out, right? You can take one big large problem statement, break it down with the help of interacting with your ai augmentation, such that you can break that down into smaller parts, such that you can focus on all of those smaller parts in isolation, right? And then it's about doing with ai, right? How do you acquire new superpowers? How do you solve more complex problems with ai? And how do you sort of transcend what you have not what you have been doing it yourself, or what you have been doing manually so far, with the help of human ai augmentation, right? I think one key thing to remember here is that the machine is going to be a lot more output focused, but it's a human being who's going to be a lot more outcome focused, right? That what is the outcome that I want to derive out of a given interaction, right? So prompting becomes a very interesting and very crucial skill that everybody needs to understand. And equally at the same time, what's also important is to understand when not to trust AI, right? Not to take everything at the face value of what the model is telling you, right? So that sort of judgment, that sort of wisdom is also required when we talk about this human AI augmentation. Yeah. Now, if you look at the software development life cycle, right, these are the typical steps of requirements, analysis, development, testing, and deployment. Right now, how do you augment this process with AI potential? Right now, these are some approximate numbers. Take them with a pinch of salt. Right, we can use AI to research, ask questions, and document those requirements. Right, we can use AI to now write stories, draw diagrams, right, generate acceptance criteria for the stories. Right, so it can be used for analysis. Right, so if you look at it from a cross-functional team perspective, which comprises of developers, product managers, business analysts, and quality analysts, there is something for everybody, right? So when it comes to development, now there are a lot of tools like GitHub Copilot, Code Whisperer that are available that can help in aiding and making development a lot more faster, right? It can provide super autocomplete for generating code. It can generate documentation. It can help you debug issues and the likes of that, right? And when it comes to testing, which we will cover in a lot more detail in the subsequent slides, we can generate test cases, test code, generate test data or stress data to mimic the real data patterns, right? So this is the overall view on how AI can augment the entire software development lifecycle, right? Now, all these numbers that you see, right, they are based on some of the studies that we have conducted ourselves at ThoughtWorks, right? But you do need to take them with a pinch of salt, right? Uh, in no way am I saying that testing is 100% and requirement understanding is only 60% impact on automation potential, right? But then this is based on our studies. You might have a slightly different experience as well. Now, this is another interesting study that was done by GitHub Research on usage of GitHub Copilot, right? And what you would notice here is a very interesting phenomenon that what is the perceived productivity of an engineer? Now, I'm very particularly using the term engineer, not just a developer, because I believe that quality engineers, software engineers are all engineers and part of the same team, and everybody has the requirement to write code. Everybody has the requirement to contribute to the software development lifecycle. So therefore, I'm talking about from an engineering perspective and talking about engineer satisfaction when it comes to talking about a lot of these tools, right? The perceived productivity that I am more productive, I feel a lot more better because I'm less frustrated by well coding, I'm more fulfilled with my job, right? So these are some of the numbers that really show that how these tools are making huge strides when it comes to lending a faster productivity, a higher productivity to the engineers who are part of a cross-functional team, right? Which ultimately means we can potentially go to market faster. We can write more software, right? We can write software faster, right? So all of these are actually proving from a research and metric perspective. With that, after having looked at what's the impact of this on the software development lifecycle, what does it really mean for engineers on the team, and what are the fundamentals of generative AI, the very first trend that I would love to highlight is know thy prompt engineering, right? As I was mentioning earlier, that is the new interface with which you interact with a large language model, right? So it's very important that we understand the nuances of prompt engineering, right? It becomes like a basic primal skill that every engineer or every person for that matter should have in order to make use of this fantastic technology, right? And prompt engineering can be thought of as all of these aspects, right? There are a variety of them. There is direct instruction, right? There is retrieval augmented, chain of thought, example based prompts, iterative refinement, and tree of thought. By the way, these are not the only ones, there are a lot more. But for the purposes of this talk, I'm going to focus a lot more on chain of thought and retrieval augmented, right? But before that, let's take an example, right? What are the basic components of a prompt, right? There is an instruction. In this example, we are telling or we are instructing the large language model to classify the text into neutral, negative, or positive, right? Then there is an input where I'm providing it the input text, which is I ordered an iPhone online, but I haven't received it in the last 15 days, right? And then I'm expressing the output format where I'm saying that use JSON as output format, include the following fields in my output, right? So I'm telling the large language model that in the output that you tell me or that you throw back, I want it to be structured in this fashion, right? And then I'm telling the output indicator from where that it's a sentiment, right? That this is where you start saying that what is the sentiment of this particular input text that I'm feeding you, right? So these are the basic components of a prompt. And if we take a look at the right hand side, some interaction with ChatGPT, it says classify the text into neutral, negative, or positive. As I was mentioning earlier, use JSON as output format, include the following fields. And the text, which is the input that I've given to the model, is I think the food was okay. And then I'm expecting the large language model to give me back the output as of sentiment broken down in these fields, right? You can see that I mentioned these fields in the output format, and now ChatGPT is responding with those fields. It says, this is the text, this is the sentiment, and this is the reason, right? All the three fields that I wanted it to have in my output, right? And so on and so forth for the others as well. So you can see that if we go back to the previous slide, I'm giving it an instruction, right? I'm giving it an instruction and making it clear for the prompt to understand what do I expect from the large language model, right? So it's the idea here is that it's all going to boil down to how well do you understand to write a prompt such that you can make most use of these large language models, these foundational models that are available to you as a service, right? Now let's take a look at this prompt, right? This is, by the way, on Stable Diffusion, which is a model that helps in generating images. And I gave us very simple prompt on a boat in a rough sea, night, dim light. Right? You can see that it generated an image which sort of matches this description, but it's still not vibrant, right? Now that's reflective because it's not a rich prompt, right? It's a very simple, basic, standard prompt, right? It's not giving out a lot of information on, or it's not detailing out the specificities that I need in my image, right? Now, if you look at or compare this to this prompt, right, it's a lot more specific. It's a lot more detailed. It gives a lot more context to my model to understand what is the expectation that I have from it, right? I want a real photographic landscape painting with incomparable reality, right? Super wide. I'm giving it the right words such that the large language model can understand my intent a lot better, right? Here I'm also specifying the aspect ratio that I want this image from. By the way, this image has been generated from Midjourney. Midjourney is another model that is capable of taking text and convert that into an image, right? The point that I'm trying to make here is the quality of your prompt is going to decide how meaningful is your response going to be, right? The better the prompt, more descriptive, with more context, with more understanding, with more clarity of specifics, the better the response that you're going to get from your language model, right? With that, let's talk about a very specific prompting technique, which I really want to focus on in this talk, which is called as the chain of thought prompting, right? Like, let's take an example to understand that a little better. What is a standard prompting? I ask it a question. I say, Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? I am also giving it the answer, by the way. The answer is 11. And then I'm asking my question that the cafeteria had 23 apples. If they used 20 to make lunch and bought 6 more, how many apples do they have, right? Now you can see this is a standard prompt, right? I have not explained to the model how to break this down or how to break down this problem in a structured, broken way, right? I've not given it a chain of thought. I directly gave it an answer that the answer for this particular question is 11, right? And therefore, it's rightly so that the model captured the answer wrong, right? It gave it wrong. But what is the difference that we can create with chain of thought prompting? You can see that's highlighted in blue, that when I gave it the answer 11, I also gave it how to think about it, right? What is the chain of thought that can be established to come to this answer, right? So I broke down the concept. If Roger started with 5 balls, right, and 2 cans of 3 tennis balls are available, where each is 6 tennis balls, therefore 5 plus 6 is equals to 11, and that's why the answer is 11, right? Now if I ask the same question to my model after giving it this chain of thought, you can see that my model is mimicking that behavior. My model is also trying to depict or reflect that chain of thought, and it's giving me the answer in that reasoning itself, right? So there's a very subtle difference between rejecting the model and say, hey, it doesn't understand how to answer, or it gets the question wrong, right? But it's an art to how to interact with the model in a way that you can provide your chain of thought to it such that it can mimic, right? At the end of the day, it's a machine, right? And the best way to use a machine is to give it a lot more specific, to give it your reasoning, to give it your chain of thought such that it can answer better, right? So I would highly recommend that a lot of you go back and have a look at this website, which is promptingguide.ai, right? It talks about a variety of prompting techniques that I believe are going to be extremely beneficial for all of you to bring it in your day-to-day business as a quality engineer, to make yourself more productive, make yourself better equipped with learning and leveraging this to make yourself do things faster, better, and with higher quality, right? The next prompting technique that I want to talk to you about is called as RAG, Retriever Augmented Generation. Now, what we are saying here is that you augment your large language model with a data source, right? In this case, a vector index, right? Where you have captured the embeddings of the text that you're likely to get question answered for, and already stored them in a vector index, right? Now, let's understand this a little better. We often talk about hallucination, right? We often talk about, hey, the model is not giving me the right answer, right? And in cases where I want to really limit and do that grounding for my LLM, right? How do I enable that? This is the way to enable that, right? I take a chat prompt, right? I go to my chaining agent. In this case, it could be a LangChain or a Llama Index, right? There are many libraries that are available which can help in chaining an external data source or an external compute or an external tool and augment the capability or capability of the large language model, right? So in this case, this vector index is acting and augmenting the capability of the LLM, right? So first, with the help of my chaining agent, I do that search for in the vector index to ground my prompt, right? To enhance my prompt and then send it to the LLM to get the exact answer, right? So if you're looking for an example on this, there is a bot that ThoughtWorks partnered with on AI for Bharat. It's called Jugalbandi bot. You can go and check it out. It's available openly. You can try it out yourself. You can check out the video that's available on YouTube, where that bot is an example of this sort of an architecture, right? Where we are combining multiple tools to augment the capability of OpenAI large language model, right? And it helps answer the questions on the government schemes that are relevant for the citizens of India, right? So it can help you answer questions effectively with a lot more controlled environment, with a lot less hallucination because of this entire architecture that you see, right? So do check it out. And this is a way to sort of control the hallucination, and this is a way to control and augment the capability of your large language model. And these are the patterns at different maturity levels, right? At level 1, you use prompt engineering to interact with the pre-trained model. The examples are Google Bard or ChatGPT. And at level 2, you use prompt engineering to interact with an agent, right? Which interacts with the pre-trained model and external tools. The example that you saw here is I am interacting with an agent, and that agent is orchestrating my interaction with a vector index, a tool, and eventually a large language model, right? So as I was mentioning earlier, the examples are LangChain or even the ChatGPT plugins, right? Then level 3 is using an advanced agent that auto generates prompts to control the pre-trained models and external tools, right? The example of that is auto gpt, where you give it a task and then you leave it to auto gpt to break that down into sequential tasks, right? So if you tell auto gpt to help you buy the best shoes for marathon running, auto gpt, because it has access to the internet, because it has access to a lot of tools, right, it will break down this task that you have given, break it down into subtasks, and then leverage anything autonomously to answer or serve that query back to you, right? To serve that response back to you. So these are the three levels in terms of maturity levels when it comes to prompt engineering, right? So if you can see, it goes on from being a lot more imperative, which is instruction based, to a lot more declarative, right, where I am not telling it how to do things, but I am telling it this is the outcome that I need, and the model takes care of, or the agent takes care of breaking that complex task down into some simpler subtasks, and then autonomously, take care of executing them, right? So level 1 is a lot more imperative, instruction based, and level 3 is a lot more declarative, or you tell it the outcome, right? Now, when it comes to how do I think of prompt engineering in the context of quality engineering, right? Automatic generation of artifacts. Now, there are variety of artifacts in the entire software development lifecycle that you can think of automating, right? You can use these models to understand the domain. You can use these models to do test case generation, test code generation, generate test frameworks, right? The retriever augmented generation that I showed you earlier is a fantastic way to think about developing your own test frameworks, right? You can create the acceptance criteria for from a quality perspective that needs to be created, right? You can create the entire testing strategy given you explain the problem statement of your software system that you're building to these models, right? And to put them into a slightly more better view to understand. So if you look at it, we can start from automating. We can automate test data creation, the boilerplate plate code creation, templates and checklist, code generation, code refactoring, although the ones that are marked with asterisk are not highly mature, right? But still doable. Then there is ideation. I can create my strategy for my tech stacks. I can create my test cases, my plans, and many more things. And then I can personalize, and then I can also analyze, right? I can analyze the test results. I can analyze the root cause analysis. I can do a defect prediction, and I can also analyze the code smells, right? So these are the potential use cases for generative AI in testing. Now, with this, we come to the next segment wherein we are going to talk about testing the AI, right? So far, we looked at how to use AI for testing, and now we are looking at how to test the AI itself, right? The other side of the coin. And the first trend that's extremely crucial to understand is thou shalt enable responsible AI, right? I'm sure all of you have heard this term over and over again. And I believe that at this point of time, responsible AI, or understanding what are the AI ethics and how do we ensure that our AI is responsible, becomes a lot more important because of the proliferation of AI tools and AI libraries all around us. Right now, this is news that you can all see, that ChatGPT was criticized for suggesting harmful actions towards Iranians and monitoring mosques, which sort of can create a lot of harmful situations for us, right? It was giving biased outputs, right? You can I think that this deck would be shared with you, so you can actually click at this link and look at this news for yourself. But it's making an ASCII table of typical human brains based on their worth in USD, right? And it's trying to break them down by race and gender, and you can see that it's rating a Hispanic or an African a lot less than a Caucasian white person, right? And you can see that it's also reflecting some of the gender biases, right? Between male and female, it's rating the life of worth of life of or worth of a human brain higher for a male than a female, right? Now you can ask, where is this? It's learning these biases from. Now it's important to understand, because these models have been trained on large amounts of internet data. And no one can guarantee that the internet data that they are trained on is free from any bias, right? They are not, right? And therefore, it becomes imperative for the people who are going to use this technology, or people who are going to use this technology in building software systems on top of it, that we enable and establish enough guardrails such that our systems are not biased, our systems are not controversial, our systems are not creating these unfair or biased outputs when it comes to usage, right? Another example here: write a Python program for whether a person should be tortured based on their country of origin. This one is quite gross, actually, and it says that if the country is North Korea, Syria, or Iran, it's okay, the person should be tortured. Now, these are some very disturbing aspects of working with these large black box AI systems, right? And as technologists, as engineers, it's imperative that we need to be aware of the AI ethics. We need to be aware of what is responsible AI all about, right? So these are the four tenets of responsible AI. It should be fair. When I say fair, it means that it's not on the basis of a demographic or on the basis of gender, discriminating, against individual or people, right? For given a same question, given different demographic, ethnicity, or gender, can my AI system be fair if it's not giving a biased output across these dimensions, right? It needs to be accountable, right? For instance, if a self-driving car hits a person on the road, who is going to be accountable, right? Is it the developer who built the system? Is it the organization? Is it the person who's sitting inside the car? Who is going to be accountable, right? So responsible AI is about ensuring that my AI systems, the entire value chain, right from the developers to the people who are using, express an accountability and have a skin in the game when it comes to accountability of any intended or unintended consequence, right? It needs to be transparent, right? For instance, if there is an AI system which is taking a decision whether you are suitable for a job or not, right? Or whether you should get this loan or not, is it transparent? Can it explain in full transparency how it arrived at that sort of a decision, right? So responsible AI means that all the decisions that my AI is making, I should be able to audit them and understand how it actually derived that decision, right? And last but not the least, my AI system should be trustworthy, right? It should be able to give me the reason why did it take that decision and on what data was it trained, such that I can trust that decision, right? So these are the four tenets of responsible AI. And with that, I think it's important for us to understand bias, right? There are a variety of bias that exist: implicit bias, group attribution error, automation bias. I think the one that I have marked in green is the one that I would love to talk about, which is automation bias. Now, there tends to be a belief that if a machine is answering something, it knows better, right? Because, and that's the reason it tunes to automation bias. And if you remember, I was mentioning earlier that in the human AI augmentation, it's going to be imperative that we don't trust the output of the model blindly, right? What are those guardrails that we are putting to control that hallucination? Because these large language models are fully capable of making their absolute bullshit sound like pure gold, right? They have that capability. And therefore, in order to not give in to those biases that these models can exhibit, we need to be very, very careful, and we need to understand them to be able to counter them better, right? So understanding all of these biases is going to be really critical. Again, I don't have the time to go into them deeply at all of them, but this is just scratching the tip of the iceberg, right? I wanted to pack as much information in this talk so that you folks can go back and understand and do your self exploration based on these concepts. Let's take a slightly deeper more look at how to think about bias. How do you think we can sort of counter bias, right? I think explainability becomes one single way in which we can counter bias, right? When I say explainability, explainability across the value chain, explainability of my data, explainability of my models, explainability of my pipelines, right? My data pipelines, which are actually crunching the data and curating that data on which the model is going to be trained, right? So it's explainability across the spectrum of what data, what data curation in the form of data pipelines, and eventually the explainable model, right? Now, if we go a step deeper, right, what are those tenets that gonna help me get all of these three things that you see in pink, right? For explainable data, I start thinking about data quality, right? Whether I can write data quality checks on my data for bias, right? For looking at whether my data is not perpetrating any sort of pre-engineered bias that it might already have, right? Which can be based on gender, which can be based on ethnicity, or for that matter demographic, right? And then comes interpretability, right? Can I interpret the decision that this data is trying to feed out? And when it comes to explainable pipelines, it's about right observability, right monitoring. And I think it's, as we go into this era, it becomes a lot more important to not just think about validation, but to start thinking about observability, right? Or to start thinking about continuous monitoring, because it's hard to test all the possible combinations even before you put something in production, right? So the new age QA in my mind is a lot more about how do you observe your systems in production, how do you monitor your systems in production, and how can you be more real time about it, right? And if we take another look at it, right, what are the aspects that we are talking about with data quality and interpretability? We are talking about holistic diversity of data, right? That whatever data I'm training my model on, it should be holistic in nature, right? It should have the right diversity such that there is no bias. I'm not saying that there will ever be no bias. I think it's a continuous, it's a continuous improvement game, right? But as a person who is responsible for making sure that these systems are explainable, can I think about testing my systems on holistic data, right? Can I check and figure out what is the diversity of data on which I should verify the quality of my data, right? And in the same line, how do I think about hallucination control? How do I think about misinformation control, right? How do I think about adversarial testing, right, with adversarial data, right? So these are some of the ways in which we need to think about testing the AI systems itself, right? The idea here is, how do I monitor the model drifts, right? The model was intended to serve a given outcome, but over a period of time, as it has learned and seen more, is it drifting from what it was intended for, right? So that becomes a very important continuous monitoring aspect, right? And one could argue, should the QA be responsible for that? And I would say yes. In a cross functional team, a quality engineer or a quality assurance person is equally responsible for thinking about all of these aspects just as much as a developer, right? When it comes to hallucination control, right, how do I monitor my model performance? How do I build the right data quality frameworks and embed the right checks in my pipelines, in my continuous monitoring ecosystem, such that I can monitor the model drift, such that I can monitor the model performance, right? How do I do boundary value analysis, right? How do I set up my system in such a way that I can take actionable alerts, right? As we start talking about continuous monitoring, you know when you get alerted, is it actionable for you? That becomes crucial, because you need to sort of filter out the noise from the actual actionable alerts, right? So the more actionable your alerts are, the more effective your monitoring is going to be, right? And breaking the AI system, how do you sort of take adversarial data, right? Adversarial testing is about testing your AI system with adversarial data, right? You try to feed it bad data and see how does it behave, right? And if it starts behaving bad on bad data, you know that something is not right in your system, and you go back and break or you fix that problem, right? So this in my mind is a good spectrum of things that a quality engineer should be aware of when it comes to testing the AI systems. This is a very simple fitness function for bias, right? There is this concept called equity of the odds and demographic parity. This is based on a Google paper. You can go and check it out yourself. But this is a very simple test or a pseudocode that is telling that what are the odds for the demographic attribute locality for a loan acceptance, right? Imagine you are a bank and there are variety of localities that you serve as your target customer segment, and is locality, if depending upon which area of the city you are coming from, is going to impact your chances of having a loan or getting a loan sanction, right? So this is a simple test which says that the true positive rate of a locality 1, which could be a posh locality, to the true positive rate of locality 2, which could be a slightly down market locality, which that's the perception, right? Are these two being treated differently, right? So this becomes a test that is there as a guardrail in my system while I'm still developing it, to ensure, or while I'm monitoring it in production, which is ensuring that the locality, which is a demographic attribute, does not have any bearing on the loan rejection and success ratio, right? So this is the way we as engineers can make sure that the systems that we build are free from bias, right? Or at least we can try to make sure that whenever we capture a bias, by continuously monitoring with all of these automation, we can go back and fix them, right? The next important trend is knowing thy stakeholders, right? I think in this complex world of AI tools and systems, there are a variety of stakeholders that a QA needs to interact with, right? Whether it's a data scientist who's helping you devise that model, whether it's the ML engineers who are helping you productionize that model, whether it's the developers who understand the domain data, whether it's the domain experts who understand that domain, whether it's legal and compliance, because it's a lot more about AI ethics. It's a lot more about the topics that we just discussed: fairness, bias, responsibility, accountability, trustworthiness, right? All of these are functions of how do you think it from a compliance and legal perspective, right? And then data engineers, right? So all of these are the people that a QA must have good relationships and good connections with, because these are the people who are going to help you make a better quality analysis of the tasks or the systems that you are analyzing, right? Because these are the people who are going to give you the right set of information, whether it's about the ethics of the AI, whether it's about the legal aspects, compliance aspects, or the technical aspects of how these systems are built, such that you can ensure right guardrails from an automation and testing perspective, and from monitoring perspective, to make sure that your systems are just and responsible. Last but not the least is know thy tools. I think the space is exploding. You can see on the right hand side the generative AI application landscape. It's already exploding with so many tools that are out there already. But it's important that we vet out what makes sense for you. You try it out. I think the only way to vet out something is to try it out, right? So don't hold back. Go out and experiment, and make sure that whatever you identify as something that's relevant is based on your experimentation, or based on experimentation of the people that you trust, right? Because there is no other way than to try it out and figure out what are the set of tools that I must leverage in my ecosystem to make myself more productive, right? Because there is so much out there. These are some of the tools that I have seen being used successfully. Again, I don't have any affiliation to these tools, but they were all featured on a publication that we create based on our experience. And these are some of the tools in the AI and ML space that have really proved that the new age quality assurance folks who are testing AI systems can leverage these tools to do data quality, data observability, and data privacy checks in a very proactive fashion during development, and also while the systems are in production. And with that, I think we're going to do a very quick demo. I'm going to do this and go to this. So this is a simple app developed by a few of the passionate QAs at ThoughtWorks. And what it does is it takes a Swagger file. So if we go ahead and show you, this is the Swagger documentation. This is a sample Swagger YAML for the pet store, right? It has several endpoints like posting a pet, creating a new pet to the store, and uploading an image, and on all of that, updating an existing pet, right? So this is the API spec, Swagger spec for this particular application. And we are gonna do contract test automation by leveraging generative AI, a large language model. In this case, it's OpenAI GPT-4, right, to generate the contract test, right? So I'm gonna give it the Swagger YAML. which is here. I'm going to open it and I'm going to tell it to set up the project. I'm going to say my test. I'm going to say choose a language, get started, and I'm going to select, say, this particular API, post. And I'm going to ask it to say generate the test, right? And it's generating the test. While it generates the test, I think I can tell you in the background what's happening. There is a prompt engine that has taken the entire swagger.yaml, parse that context, and send it to the large language model. And based on that, the large language model is generating this packed based test, consumer test, which now I can, as a QA, take in and make my development faster, right? So this is one simple use case of how generative AI, with the help of extra chaining on top of it, which I showed you in the slide as well, can do wonders and automation, and can take your automation game to the next level, right? With that, I come to an end and I'll be happy to take any questions.
Wow, that was an amazing talk on the key trends in Gen AI that all QAs must know. Thank you, Anya. Folks, have you ever thought about how we could redefine our work with generative AI? Well, think no more, because our next speaker is going to tell us just that. Ladies and gentlemen, please welcome Gaurav Mahajan, Technical Director at Globant. Gaurav is another renowned speaker covering topics including DORA, test pyramid, test automation, shift test lefts, and quality acceleration. Over to you, Gaurav.
Good evening, everyone. This session is going to specially talk about how Gen AI is actually solving problem for us. What are we doing at Globant to solve certain problems with respect to how we develop, ship and test our softwares. Vanya just spoke about the trends, what we should be aware of as part of the QE community. And here I'm going to show you some of the solutions which are already in place in Globant, which we're using to develop and ship our solutions. My name is Gaurav Mahajan, and I'm going to take you through these three solutions in the next 45 minutes. So essentially, we're going to talk about how we are redefining the way we work with the Gen AI and LLM model. But before we get more into it, I'm going to set some context. Uh, there is this understanding already in place that in next 3 years, 80% of AI-centric revenue will come from the AI-centric services, and 65% of consumer interactions are now digital thanks to the pandemic we had. So having said that, we already understand and anticipate that 60% of the companies are actually trying to transform themselves in the space of digital transformation. But unfortunately, 70% of the transformation are unsuccessful. And that is exactly where we come in. So a little about Globant. We are running in our 20th year of existence. And while we are here, we already have quite a bit of mindfulness around how AI can change the way we are working from some time. It's not like now that we are talking about Gen AI, Chat GPT, but I think we at Globant were working with idea of including Gen AI from about a decade now. So our footprint is around 32 countries. At the moment, we have 27,000 Globers, and we are at the moment looking at 37.3% of year-on-year in growth. As I was talking about AI mindset, that is something which was in place. I'm going to double click on this a little in next 3-4 slides. Our focus with AI was to drive better outcomes and elevate the customer experience. I'm going to showcase 3 AI platforms which we have developed: Magnify, Agor, and Genexus in this whole session, which going to cut across how we are developing software, testing them, and how we are enabling developers to have better understanding of the software and on the code which they are supposed to work on. Having said that, a little more context on how we have crafted, our services, keeping the AI mindset. You can see some of the important key points. We we anticipated that the consulting, IT consulting, will move into an AI based flavor. Business reinvention solutions, adoption, how we can basically enable our customers to adopt AI model. What can be an ROI framework around that? Trainings, staying relevant, how the customer experience is going to change with this, and of course how the whole AI transition can be safe, and our manifesto and our vision around it. As I said, we started our data and AI studio back in 2013. It's almost 10 years. And over the years, you can see that we have developed our manifesto, products like Agor, Magnify, Genexus, which we're going to talk about. And here we are today. First and foremost, I'm going to talk about Agor, Genex, and Magnify AI. We will start with Magnify, go over to Agor, and then Genexus. So, what is Magnify? Magnify is an AI based solution which enables visual testing in a more automated and AI specific, Gen AI specific way. What are we going to talk about here is visual validation or tests which run on the UI layer, but how we can reduce the time around this in a more, not only automated but in more intelligent way with help of Gen AI. So what you see on the screen is basically there are two images. It has around 7 different differences between these. And if I have to test this manually, of course it'll take some time, but with AI it's going to take probably less than few milliseconds. The point I'm trying to make is there are different use cases which AI can easily solve when it comes to validation around images, their placements. For example, searching image within other images, locate elements within an image, and compare images. I'm going to quickly show you the 3 use cases. So first of all, image search. In this use case, as described on the left-hand side, we use an image search algorithm to validate the number of times an item appears on the screen. And I'm going to show you a quick example of an airline application where we are going to look at the booked seat on the whole seat map for a particular airline. So now if somebody has to do this manually, it'll take some time. They have to manually count it, scroll through the image or scroll through the whole page and understand that how many of them are booked, how many of them are not booked, or are they working fine. But in this case, in the start of this video, you saw that how that seat icon or the seat PNG was taken as a reference, and now it is actually going in and going to quickly check right on the screen that how many of the seats are available versus taken. And here you can see the expected results versus the actual results. And yes, that's about it. Quickly over to the next use case, which is locating the relative position of any image. And in this case, we're going to use a locate algorithm to validate relative positions of 2 components inside an image. So again, just a quick demo around that. These are the images. These are 2 images, left and right. And now, while the test started executing, launch the browser. Navigating over to the page. Taking some time, and yes, here is the image. These are my test results. I can see both the images, the relative positioning, and that's about it. So the last but not the least, a very powerful image comparison, which is basically an apple to apple comparison between an expected and the actual image. A lot of people have done these kind of tests using open source libraries, like using a Java library with Selenium to do an image comparison pixel to pixel. But the problem there is that it does not work with different resolutions, and that is a problem which we have solved here, where there is powerful image comparisons between actual and expected, pixel to pixel, agnostic of resolutions, and saving massive amount of time, which basically goes into visual validation test cases. And even through automation, I think it reduces a lot of time uh, compared to the conventional way these cases are automated. So while I have spoken about uh, image comparison capability, I'm going to just quickly tell you that as a summary, we are able to check expected layouts, test screenshots, resulting images with Magnify AI. You can see this quick example here. When we compare, this is the expected, layout. This is the test screenshot. This is compared. We know what are the changes, what are the differences, and we are quickly able to basically go over and record these observations. But that's not all. We are trying to solve problems across the pyramid and not only visual validation. With our latest version of number 5, version number 5, we are also looking at solving more complex problems, and going deeper into the test pyramid. What you're looking at it is how this tool can also help you to spit out skeleton codes based on the type of test, the kind of framework you're using, and the language you're using. And what you're looking at the screen right now is it can also help you to generate manual tests in a more conversational way, just like ChatGPT, but in a much more better way. So what it does, saves time, enables faster development, helps us to shift left, and even aggregation of time taken for development of UI tests is massively reduced. Having said that, if you want to know more about this, I'm putting the email ID where you can put in your queries. You can go over to the internet, have a look at Magnify, and that is something which some of our customers have already started using. The second part I'm going to talk about is about Agur. Now, what is Agur is basically it's an AI-powered code intelligence platform. So what do I mean by that is, hypothetically, a lot of developers actually spend time in understanding codes written by somebody else, and that's sometimes the reality of our projects in services or products. We anticipated that this problem is huge with respect to the time they actually uh, invest in writing the codes, or getting the requirements polished. Understanding any code takes massive amount of time, and that is where it creates a lot of work in progress in the work stream of development. And if you are somebody who understands the philosophy of lean methodology, we need solutions which can allow engineers to work in their respective work stream with far more ease without investing time on things which are bureaucratic or counterproductive. Now, documentation is one such challenge which hampers the productivity of a developer time and again. So, we wanted to develop something which can help and enable the developer to understand the code quickly so that they can focus on solving much more complex problem rather than going through a code and understanding it line by line. So that's why I go. So what do we do? Our purpose is basically to empower teams with AI to create smart softwares which can simplify development and helps the developers to focus on more innovative solutions and engineering excellence. Of course, this is our value proposition. We anticipate that on an average, developers spend 70 to 90% of their time performing program behavior comprehension in some way or the other, right? And the mission is basically to help these teams. And solution is, of course, Agar, and which enables comprehensive code waves, documentation or enables comprehension for different codes and accelerate their go to market. So again, benefits: exploration, documentation, and collaboration. These are the low hanging fruits we foresee, and I'm going to show you a quick demo to show you how basically it works. So as I stated, helps developers to understand code. Let's see how. You can easily go and look into a particular GitHub repository. You can actually log in through Agor to any GitHub. And if you have if you have certain repositories, you can subscribe to that. And here I'm trying to, search reply to a message related code. It basically gives me the files, of course, where the code is, and it also provides a comprehension of that. Not only that, it also along with that gives me a code map which you're looking at it. And this is the code which I was looking at, reply to message. And now this is an interesting part. So now when we kind of zoom into this, when we double click on that code snippet, it also gives me bugs, which is basically an inspiration from the static code analysis. It also gives you 5 code smells, couple of bugs, and a cyclomatic complexity score. So that actually tells me that how good or bad the code is. So I get like a very zoomed out view, which I can zoom in, go into it, understand vulnerability issues and health, and that's the the tip of it. I strongly recommend you to spend some time on Agor and see that how it can actually help your team. Of course, as I said, 70 to 90%, this is the industry today. 70% of understanding time of developer goes into code comprehension, and 14% in UI interactions, meetings outside IDE, maybe editing, navigation. And what we see is, we can solve this problem with Agor. This is a quick comparison of Agor with SourceGraph, and you can see that how we have developed our capabilities a little better than SourceGraph in core technology, a code search, automatic documentation, which is the core strength, and the languages and traditional documentation piece as well. Having said that, we see that who needs a core, maybe a mid-level technical lead, who's handling a large a team inside a large organization, and have a number of repositories for his team to work on. And that is where we can provide some solutions and benefits around productivity, quality, and team. And the person who's going to use it, or the developers who's going to be using it, is probably with 2 to 3 years of experience, 1+ years of experience, who needs to be more productive uh, and gain more experience around how to navigate through documentation of code, uh, and in adhering to the right development KPIs, Agur can do wonders. So, if your team wants to improve the code's health, reduce the time in taking over an existing product, doesn't want to deal with a lot of spaghetti code, scale your development team, downsize your technical debt, and you know want to reduce or completely end your tribal knowledge, then that is where the solution can help us. Again, for lead level, better control on documentations, insights, getting more insights, how to manage the complexity, and detecting potential problems and opportunity. That is the benefit on the lead side. On the developer level, of course, onboarding is going to be faster, ticket resolution is going to be faster. Uh, any chartering into unknown territory in terms of code is going to be easy, less anxiety for the team, and code reuse and knowledge sharing is going to be faster. If you want to know more about Agure, you can send a hi at agure.com, and our teams are more than happy to get in touch with you. And quickly, let me take it to Genexus. Now we have spoken about how to test softwares, how to understand softwares, and now let me tell you, or let me introduce you to Genexus, which is basically a software which helps to develop the software, or in fact, not only helps but also develops the software for you. So Genexus is basically a code generator uh, with AI capabilities and assistance, so that your development time and the way you are developing time can reduce, and the way you are developing can improve, right? So the key benefits is speed, flexibility, scalability, and cost effectiveness. And the target audiences are basically businesses, services, which needs quick business adoption, and also need to reduce the time to market, essentially. So what are the different technology involved in Genexus? Now, while Genexus is a platform independent development environment and code generation platform, we have some proprietary programming languages called Genexus Script. Uh, and this basically have an inbuilt compiler for the Genexus script code. It supports a variety of integration technologies, web services, API connectors to other databases. And how it essentially works is that applications are created using a visual development environment called Genexus Studio. Genexus Studio, of course, provides drag and drop interfaces, as well. But at the same time, it allows you to provide your uh, requirements based on which it can spit out a skeleton application on which you can build. And not only skeleton, it can go into great details if you're very specific about your requirements, just like any other conversational AI chat based solution like ChatGPT, right? So having said that, right, uh, how it works is it works on the concept of design ops. How we have implemented design ops here is that is what this slide is trying to summarize. So design ops is a discipline which combines the design, development, and operation. So in simple words, if I have to tell you that, if I can say that want to, create an application which can hold user data, all the demographic data for a user. I know there's going to be a login, a module. There's going to be a form which a user has to fill in. I have to define some basic information: name, age, Aadhaar, address, telephone, etc. So there is already a lot of known knowledge and information around different modules, different solutions pertaining and coming from different domains. And design ops can help us to assemble the intelligence of these modules across domains without having to reinvent the wheel. And that is essentially what is doing we are trying to do with Azure. A lot of teams have written code to implement login, which essentially is time and again buggy. I think it's counterproductive to write a code for a module which is already out there in some capacity. And when you need it, it should be there at your disposal. So keeping that in mind, Azure works. So what it does is, based on your requirement, it generates code. It generates code on various platforms, like for mobile devices, for servers, for web. You can see some of the uh, tech boxes, which tells you that what are the capabilities. It automatically deploys then that code in all these different platforms, from AWS, SAP to OpenStack, etc., which you can see on the screen. And it automatically also generates and maintains the database which is needed for these applications to use. Having said that, where exactly the Genexus fits in? Any customer facing apps, mobile apps, back office apps, web apps, I think we are capable of doing it real quick. So while I have spoken about where Genexus can fit in, let me show you a quick demo. I'm going to show you the login of Genexus Next, which is a web-based solution. I'm already logged into this, and you can see that there are certain samples of certain domains which are already there. And here I can also see some of the projects which I have been working on. How it actually works is, now let's say I need an application for customer support. And if I ask this question, uh, just a very simple, plain vanilla, it basically tells me what kind of application it can suggest. So I say, okay, fine, I need this application where there are 3 and 4 customer entities. I mean, there are business entities, customer support ticket, able to log in tickets, handle tickets. There is going to be an agent which is going to be looking at it, and maybe I want to have a knowledge base so that all the how to questions are resolved by looking at that knowledge base and not having to raise a ticket with customer support. So, and it basically gives me a template, and it allows me to pick and choose the the knowledge base tools. I want to use SAP Fiori, it can do that. I can use a knowledge base tool as well, and I can go ahead and publish this. And as simple as that. So it takes some time to basically go ahead, starts creating the database around it, and then gives me the skeleton application with the basic functionalities in place, and then I can build on top of it if I want to. However, in the interest of time, I've shown you a very low hanging example. You can actually give it a little more complex requirements, where it can look into uh, suggesting based on those requirements that what kind of applications will do well. I have looked at this application in the past, and I can quickly show this while that application is brewing up. And this is just a simple IT application where I needed to have a dashboard which tells me about what is happening. The services, it gives some sample data which I can edit easily. Maybe my services are website development, software, custom software development, database development, etc. It also dumps in some dummy customer information. It allows me to have more using this form. Also allows me to export this, right? And if you look at the API dashboard, it also gives me standard set of APIs for all the entities which are there. Let's say complaints, contracts, customers, payment methods, support agents, general services, knowledge based generations, etc., etc. Right. So I already have an application dealing with customers, having the capabilities of integrating payment systems, contracts, tracking their services in no time, in absolutely no time, right? And now let's go back to this. This is still growing up, and you can see that all these different modules have sample data in it, right? And going back to the API, you can see the level of details which are there for the APIs which are Brood and Sprout. And yes, let me quickly check. All right. So while this project is still taking some time, I'm going to, take a couple of next minutes to summarize. So, three solutions in place. Magnify AI, which started with an idea of automating visual validations with the help of Gen AI, and now moving towards helping the test automation engineers with code specific to a particular framework, specific to a particular testing type, and specific to a particular language. And we have plans and roadmap to increase the depth and width of Magnify AI to solve every layer which is there in the test parameter. Agor, which helps the developers immensely to cut down their time to comprehend the code in the right manner, and also enables them to see the static code analysis aspects like vulnerabilities, code smells, defects, cyclomatic complexity with rather ease and convenience of click and drag. Then comes the GenXS, which allows us to develop or to brew application real time with limited set of requirements, gets the context in very few words, suggests solutions, suggests best practices, suggests low hanging components which can be plugged in no time, and gives you an up and running deployed solution which can be used, scaled, and customized as per the demand. Having said that, I'm going to thank you all for your time and attention to this. You can go over to the internet, look for GenXS, log in, spend some time in GenXS Next, and see all these things along with Magnify and Agor in action. I hope you found this session relevant and interesting. And that is how we are trying to help our customers to reduce their time to market. Thank you so much. Have a great day ahead.
Thank you, Gaurav. That was an indeed wonderful deep dive into how we could redefine our work. That was an awesome participation from all of you. Wonderful to interact with you all, even when it's virtual. We had two amazing days full of interesting sessions. Hopefully, you all liked it as much as we did. We look forward to seeing you at our conference next year. Until then, this is Deepa signing off